In this short video, we'll see how to use a vacuum fluorescent display, or VFD for short. Unlike the retro-looking Nixie tube, the VFD looks closely related to the semiconductor LED display, though in reality it's closer related to the basic triode valve or vacuum tube. The triode valve on the left of this image is actually a VR137 300 MHz triode introduced in 1946, seen here working today in my own one-valve super regenerative radio. A basic triode valve consists of three main items. Firstly, the anode or plate which surrounds the internal workings of the device, a grid of fine wire surrounding the anode, a filament or heater which is in the centre of the grid. With mains valves there's usually a separate coated cathode which is indirectly heated by the filament. The principle, however, remains the same for both types. These three items are in an evacuated envelope to make a simple triode valve. If the anode has a positive charge when related to the filament or cathode in the case of an indirectly heated valve, varying the charge or voltage on the grid will cause corresponding flow of electrons to the anode. Here we see the anode of a VFD display. This time the anode is small, shaped, and a coated piece of metal affixed to the back of the display. The display grid is a very fine perforated electrode through which the anode of the display can be seen from the front. The display filament usually consists of a number of very fine wires, in the case of a multi-digit display, crossing over the top of the grid from side to side. When the filament's heated, there's a positive charge or voltage on the anode related to the filament, and there's a positive charge or voltage on the grid, then the electrons will flow to the anode and the fluorescent coating will visibly glow. Here we see a rear and underside view of the display I shall be using in this demonstration. For displays like this one, which we've recovered from a piece of equipment, one's unlikely to be able to find the data sheets given the pinouts, etc. It's therefore fortunate that the details are usually quite easy to find simply by looking at the display itself. In order to display many digits in a single package such as this, the thing will have to be multiplexed. This is where all the anodes are connected together, and each digit is selected by activating the appropriate grid. By scanning this quickly, it will be possible to show all the digits at once. In order to identify the connections, here we can see what the display looks like close up. Note that the grid mesh only covers certain parts of the display. The 5 filament wires can be seen traversing the display on the horizontal. Using what we can see here, it's possible to identify the following connections. The connections here to the filament are either side of the display. The 9 connections to this side display are the grids, with the 9 being the anodes on the other side, which are connected together via the circuit board behind, thus giving all the A segments joined together, the B segments, the C segments, the D segments, etc. Obviously all the other little anode graphics in the section, such as the H, M, SP, LP, etc. are associated with the digit under that particular grid mesh and are accessed using the 2 spare address lines for that specific grid. Here we see a typical circuit which may be used to drive a VFD. Note the specifications for the correct voltages vary from display to display. These are the values that work well for the one I'm showing here. Note the total of 18 transistor stages will be needed to cover the whole of the display. If only part of it is needed, say just 4 digits for a clock, then you need 7 transistor stages for the segment anodes and just 4 grid drives for the multiplexing. To add a flashing colon, you will then, for example, need an extra anode line which drives that particular feature. Here we have the display on its board with the interface transistors, as you can see here, all 18 of them. If we look at the bottom of the board, there's not much to see, it's just a few bits of plain soldering, a couple of links here. The other wiring to it is actually done through the wiring combs you can see here and here, which goes to the pins on the back through some plugs and sockets. It seemed easier doing it that way. The connections to the bottom of these resistors are the ones that actually are driven by the microprocessor or whatever, and they come out on the bottom, so it seemed easier not mixing those up with the little wires here. Okay, so we've connected up all the wires to the power supply. We've also connected through some resistors to just 2 examples here, one anode, one the grid here. If we turn on the power supply, click, oh yeah, look, something works. That's just picking up one of the other digits on the display. What I'll do is I'll move the anodes around to show that with the grid on the end, this is the end grid here, connected here, changing the anodes around should give everything within that segment. So hopefully I won't skate the thing around a little bit while I do it. Let's take that off and let's have a look at the other ones. So these are the segments of the display. Oop, there's another thing there with some writing. That one's the top one, and that's the one below, and that's the one at the bottom. So those are the anodes. I click him on there. Right, now if we look at it, we're actually on that particular, that's the A segment on there. If we now move the grids around, we should be able to hit the other segments there. So we have that one, that's the next digit along. That's the next, it's part of that little sort of what looks like a tape recorder type thing. Now we're going on for the same segment note on the other ones, including the very small ones down there. So that gives some idea of what you can actually do with one of these displays. And obviously if you just want the one digit, you connect up the grid, and then moving this around will give you all of those 7 segments of the display plus the extra bits if you've included the interface transistors for it. If you want 2, then you would have to multiplex between changing the grid here. You'd need 2 of them connected up, so 1, and you scroll through the bits you need for that digit, then you go to the next one, and obviously the computer or whatever will do that really quickly, so you just simply see the 2 digits up at the same time. Anybody recognise this from our last video? This is the Z280 board. It's a Z280 at the top, and it's actually finished. Note the extra, there's the real-time clock battery at the bottom, there's the 8255, and this we're going to be using today to drive our VFD display. As it's lying around, it seemed like a good idea to write a simple program in it to make the VFD work. The wiring up of the display is much the same. They're the 3 power connections to the back. There is also 1 grid connection, because obviously at the moment we're simply running, these are the 7 segments for the 7 segments we want to use for one of the digits, but we still need one of the grids connected, and this grid will identify which one of the grids are going to be used. What I'll do is I'll quickly swap them around a minute and you can actually see them all working. So when we power up, hopefully the thing should work. Remember, we're having a signal which is changing all the time from the Z280. If we power it on, click, and go, first digit works, and we're simply running through the numbers. So the Z280 is simply going around, and it's the segment decoder obviously is decoding the numbers from the counter to give the correct digit here. Now if I quickly change these around, we should be able to see things moving. So let's move that to, that one. So next digit along. It's interesting. Not quite sure when one would ever use those, but hey, it's there. Did we try that one? Oh yes. Don't know what that is. Look on the other side, what's on this one? Oh, this is one of the small displays in the middle. And the one, that's the one next door to it. That's one of the bigger ones. That's the next one. That's the next one. So there we go. What I'll do now, for anybody still interested in the Z280, is I'll put the program back in to show the real-time clock working, which has absolutely nothing whatsoever to do with this. But as far as this is concerned, that's our VFD display. I'll put the circuit up at the end in case you want to take a screenshot of it, explaining how I actually made this one work. But as I say, unfortunately, it's not usually easy to find the data sheet for one of these, so you're really a bit stuck with knowing how much power to put in, etc. Just exercise a little bit of caution with turning up the filament too much. Some people say have it until you can see it glowing. I don't agree with that. I've never seen this one glowing yet, and I'm rather afraid if I do it too far and it blows it, then it's a bit of a waste of time doing this in the first place. So I'll go back to the Z280 just for the last little bit, just to show the real-time clock working. So this is with the real-time clock chip in here. This actually is a copy of the EEPROM in our central heating controller that uses Z280. What a strange thing to have in your central heating. It's been there for many years. And so therefore what I did was I made sure that the porting was the same as this is on the central heating controller, which means that that will run straight through without me having to rewrite an entire program for it. This is, as I said before, this is the 8255, which controls out. It's a very useful little chip if you haven't used it. 3 lots of I/O ports plus interrupts, etc. 8 bits. You're going to either go in or out, take your pick. I was using the outputs here to drive the display a second ago. If we turn it on, hopefully it might work. There we go. So it's 1019, it's about the same according to that watch. Interestingly, it runs through certain sequences here. It comes up with TMR like there, which is just telling you it's actually looking at the sensors in the house to see what the temperatures are, etc, etc. But otherwise, there you go. That's the end of the Z280, I'd say. Hope you enjoyed this video. Hope it was of some use on the VFD displays. As I say, I'll put up the circuit diagram now, just in case anybody has one and wants to experiment with it. Thanks for watching.